Welcome to the 7th lesson in the topic of statistics for CSEC mathematics. In this lesson, we will learn about the measures of dispersion such as range, interquartile range, and semi-interquartile range. We will start by defining the range of your data. I want you to think of your data as a racetrack whose length spans the entire dataset. The range is like the distance between the two ends of that track. You are simply measuring from the start of the track, the lowest value, to the finish, the highest value. Once you subtract the lowest value from the highest, you get the range. It is easy to calculate but can be misleading if outliers are present, so we will use other methods for those cases. Let's look at this example. The test scores obtained from a class are 12, 15, 20, 25, 34, 21, 16, 13, and 35. What is the range of the dataset? First, we identify our max and min values, which are 35 and 12 respectively in this case. Then we find the difference, which is 23, and that is the range of the dataset. We also need to be able to obtain the range when the data is grouped or binned into intervals. In this case, we lose exact individual values. To approximate the range, we assume the smallest value could be at the very start of the first class boundary, and the largest value is at the upper boundary of the last class. Subtracting these gives the overall range. Consider the following frequency table. When we consider this example, we can see that the data has clearly defined boundaries. So the upper boundary of the last class is 40, and the lower boundary of the first class is 0. So the range is 40 minus 0, which is 40. Before we talk about the next two measures, we need to discuss quartiles. Quartiles cut your data into quarters. If you list your data in ascending order, the first quartile is where 25% of values lie below it. The median, Q2, is at 50%, and the third quartile, Q3, at 75%. The formulas shown give the position of each quartile. If you land on a fractional position for a discrete situation, like 3.5, your average between the third and the fourth will give you that quartile value. Here's an example to show how to find quartiles. Consider the dataset 5, 7, 8, 10, 12, 14, and 16. There are 7 values here. The median, or Q2 value, is in the middle of the dataset, where half of the data lies above and half of the data lies below. This is the value 10. The Q1 is the median of the lower half of the data. The lower half of the data is 5, 7, 8. Therefore, Q1 is 7, which is in the middle. The upper half of the data is 12, 14, 16. The median of that data is 14. Therefore, that's our Q3. If we use the formulas, we can see that we got second value position, fourth value position, and sixth value position. If we look at the dataset, the second value corresponds to 7, the fourth value corresponds to 10, and the sixth value corresponds to 14, which we already found. As mentioned before, the range can be skewed by outliers. So to avoid this, we use the interquartile range, which is less affected. It zeroes in on the heart of the data, ignoring the top 25% and the bottom 25%. By subtracting the lower quartile Q1 from the upper quartile Q3, you get a sense of how close or spread out the middle values are. By using the values of Q1, Q2, and Q3 from the previous example, we can see that the interquartile range for that dataset would be 14 minus 7, which is 7. Last is the semi-interquartile range, or SIQR, which is sometimes called the quartile deviation. It tells you how far the middle of your data extends on each side of the median. Let's calculate the semi-interquartile range for the previous example. We had an IQR of 7, so therefore the SIQR is going to be IQR value divided by 2, which is 7 over 2, and we get 3.5. Doing the same for group data is a little bit challenging, but once you get the hang of it, it's as simple as previous. To figure out the interquartile range and semi-interquartile range for group data, we need two things: a cumulative frequency table and an OGIV. First, we look at the cumulative frequency table to find the total number of values n from the last row. Once we have that, we use the same formulas we learned earlier to find the positions of Q1, Q2, and Q3. But we need the actual values, and that's where the OGIV comes in. We locate each quartile's position on the cumulative frequency axis, draw a horizontal line to the OGIV, and then drop a vertical line to the horizontal axis to get the corresponding quartile values. Once we have those, we calculate the IQR and SIQR just like we did before. Let's go through this example to estimate the interquartile range and semi-interquartile range using the cumulative frequency table. The first thing we need is the total cumulative frequency value, which we find in the last row of the table. In this case, it's 25. This tells us the total number of data points, which we will use to find positions of Q1, Q2, and Q3. Since we haven't learned how to draw a cumulative frequency curve just yet, I'll provide one for you later. For now, focus on using the formulas to determine where the quartiles are positioned. Once we have those positions, we can use the provided OGIV to estimate the actual quartile values and calculate IQR and SIQR just like before. Now that we know n is equal to 25, we can use the formulas to determine the positions of Q1, Q2, and Q3. When we plug in the values, we get the 6.5 position for Q1, 13th position for Q2, and the 19.5 position for Q3. But we still need the actual values. To do that, I'll locate each position on the cumulative frequency axis, draw a horizontal line to meet the curve, and then drop a vertical line to the horizontal axis to get the quartile values. Now let's read the values directly from the OGIV. We start by finding the positions we calculated earlier, 6.5, 13, and 19.5, on the cumulative frequency axis, or the vertical axis. For Q1 at 6.5 on the cumulative frequency axis, we trace across to the OGIV curve, then drop a vertical line down to the x-axis. That gives us a value of 2.6. For Q2 at 13, we follow the same steps. Move across from the cumulative frequency axis to the OGIV, then drop down, and we get 3.8. Finally, for Q3 at 19.5, we repeat the process and read the corresponding value on the x-axis as 5.25. Now that we have our quartile values, Q1 is equal to 2.6, Q2 is equal to 3.8, and Q3 is equal to 5.25, we are ready to calculate the interquartile range, IQR, and semi-interquartile range, SIQR. Just like before, first we find the IQR by subtracting Q1 from Q3, and we get 4.25 minus 1.5, which is 2.65. This tells us how spread out the middle 50% of our data is. Next, we calculate SIQR, which is simply half of the IQR. So we get 1.325. The SIQR helps us understand typical variation within the central position of our dataset, and that's it. Let's recap this lesson. We started with a range to learn how wide the data is. Then we learned how to determine the quartiles of our dataset. Then we use the quartiles to determine the interquartile and the semi-interquartile ranges. Thank you for joining me in this lesson. Remember, you can find this content and additional resources on the website linked in the description. If you have any questions, feel free to ask and I'll be happy to help. See you in the next lesson where we will discuss standard deviation.